Hi and welcome to a new 3DE4 tutorial. This course demonstrates how to solve a shot with individually moving objects. For this purpose, we will track features in both set and moving object in two different point groups. Further, it is shown how to apply correct scaling to these two. So, with no further ado, let's start with importing a shot. All footage needed for this course can be downloaded from section Download at 3DEqualizer4.com. This big archive contains a folder with all sequences being used in 3DE4 basic tutorials. Okay, select button, browse. In folder Tutorials 4, we can find shot Trackboy Slip. Import this sequence. Let's compress and cache all images by exporting them to a so-called image buffer compression file. This feature saves the compressed shot into a single file within the same folder as the footage and within the memory. Perfect. Let's examine the shot. We see handsome Trackboy playing with the blue box, while the camera slightly moves around him. In the next steps, we will track features on the background and floor for solving the camera, and on the box to solve, well, the box motion. Let's begin with the camera. As learned in 3DE4's introductory project, at least 6 points are needed to reconstruct the camera's movement. We see the wall provides plenty of nice features for tracking 2D points. All points that are being tracked are organized in a point group. Within a new project, like we had at the beginning of this course, by default there's always a single point group already created. Having a closer look, we see point group type was set to camera, perfect for our purpose of reconstructing the camera's movement. Type object will be needed later for reconstructing the blue box. The current name is quite generic. Since we will add a second point group later down the road, let's keep things clear and choose a name for this camera point group. Maybe something like Studio. Alright, back to tracking. Let's choose a feature on the wall, like this marker, and create a 2D tracking point with Ctrl and left click. By default, a newly created point's tracking mode is set to Pattern, but here we like to track a marker. So, change parameter tracking mode to marker either in the attribute editor or by right-clicking on the point in Object Browser. Further, change color to black for better visibility. Gauge marker to center the point on the marker. And center to D to keep the point visible in the center of display area while tracking. Everything's prepared, so let's start. Nice, the point stays perfectly on the marker. Alright, let's continue with the next one. As previously, look for another marker and create a new tracking point. Then adjust the tracking area a bit to exclude the nearby marker. A quick workflow tip. With default point settings, if an existing point is selected while creating a new one, settings like tracking mode and color are inherited by the new point. If not, default point settings are applied. These default settings can be modified to our individual needs. Simply open script point defaults either as a separate requester or add it to your pane layout. Here, we can set all parameters related to behavior and appearance of a 2D tracking point. In our project, we surely continue with marker tracking, so we can set tracking mode to marker. Now we don't have to worry about having a marker point selected every time a point is created. Color black suits quite fine, so set this parameter as default as well. To prove these individual settings are now really the point defaults, let's quickly create a new point without having an existing one selected. Great, a black marker tracking point was created. It's working. back to point 2. Okay, again, this point has to be gauged, this time with shortcut X. Also again, the tracking point stands perfectly on the marker's center. Continue with tracking until we have approximately a dozen points. Nice! We have some points tracked across the entire sequence and footage. All points are associated with Pointgroup Studio, which will be used to solve the camera. Well then, calc the current project. We got a nice result. Deviation looks good, but deviation curve isn't ideal. Especially the big rise towards the end indicates some errors. But for the moment it's working. We'll optimize this later in this course. Check reconstruction in 3D orientation controls. When playing the sequence, we see camera is moving smoothly and reconstructed 3D positions seem reasonable as well. A good check of the reconstruction quality are 3D elements. So we will reconstruct the wall with the help of 3D points. Select all green 3D points except these two belonging to the floor. Then select 3D models, create, mesh from points. Leave settings as they are. And here we go. As promised, a mesh was created. Just this polygon at bottom is quite redundant, so remove it with tool Remove Poly. Okay, we have a great mesh. Now to check reconstruction quality, switch to Lineup Controls. Here we see the footage with 3D objects as looking through the camera. Play the sequence. Looks great. Camera was reconstructed. Now let's face the challenge of doing the same for our blue box. Therefore, go back to Manual Tracking Controls. Tracking points on said box with the current setup would mess up the project. Currently, new points would be assigned to Pointgroup Studio and therefore used to reconstruct camera motion. And obviously, the box is everything, but not a part of the set. So, we need two separate points for set and box to tell 3DE4 which points should be used for reconstructing either camera or box. We need an individual point group which will contain all points of the box. Right-click on Pointgroup Studio. Then select Add New Point Group. Here we go. A new point group appears in the list. Have a closer look and we instantly recognize the point group's type was already set to Object. A 3DE4 project always comprises a single camera point group and optionally multiple object point groups. We also recognize Pointgroup Studio is displayed in a yellow color. This indicates the so-called current point group. Further, the current point group is listed in the status bar at bottom. 3DE4 separates between a selected and current point group. If a point group is simply selected, we can modify its attributes, whereas the current state defines the content of point browser, deviation browser, timeline and curve editors, and of course the 2D tracking points in display area. So basically, with current point group, we set mostly everything we see in 3DE4. And in our case, which tracking points belong to camera solve and which to reconstruct the box movement. Pointgroup Studio is the current point group, but how can we set one to current? Either by double-clicking on the list entry, or right-clicking and selecting menu item Set Current Point Group. Easy, right? Please note the differences between selected and current. Pointgroup 2 is current, so point browser is empty, and deviation browser of course shows no calculation results. Studio is selected, so its attributes are displayed in Attribute Editor. Alright, let's work with the current. Like previously, we should give it an appropriate name, like box. By the way, a few moments ago it was stated that 3DE4 only can comprise a single camera point group. So if the object point group is set to camera, the previous camera point group is set to object automatically. Better we do not mess up the existing set of points for solving the camera, so fix the types. Everything's prepared, so we can start tracking the markers on the box. Zoom in to a marker and create a point with Ctrl Left. Due to the individual default settings, a marker tracking point was created. Adjust the tracking area. Then gauge the marker point. Next, track. That was quick. Let's check the track. Yep, looking good. It's approved. The next one is already waiting. Choose another marker, then create a new point. 3 quick tips at this point. First, the box markers are very close to each other, so adjusting the quite big tracking area every time would be annoying. Let's set the current size as default by selecting Edit, Set Default Tracking Area Size. Second, the white cross displaying the center of field of view is quite annoying as well, having most of the box markers around it. Let's hide it by deactivating option View, Show FOV. Better. Third, if 3DE4 is able to track a point faster than we can see properly, like point 1, there's an option to force 3DE4 to a slower tracking speed. This slower speed can be enabled with button Fast beside the track buttons. Clicking on it changes the label to slow. And here we go. It's really slower and easier to follow the point's movements. Continue to track the remaining markers on the blue box for a precise reconstruction. By the way, in case of tracking errors, 3DE4 provides a tool to display markers only by masking out everything else. The image controls. For a detailed demonstration of image controls, please have a look at Introductory Project Part 2, starting approximately at minute 31. Okay, all markers are tracked. Nice job. We have points on the box and on set, each assigned to their correct point group. So let's calc all from scratch. Nice. Deviation value and curve look fantastic for our box. And since we didn't change anything in Pointgroup Studio, its result is unchanged. The curve still rises towards the end instead of staying around the same value throughout the shot. We should improve that. But before, just as a quick reminder, as we learned previously, the editors and browsers in 3DE4 only display data associated with the current point group. For a good solve, the lens always needs to be adjusted to reconstruct the lens used on set, in terms of distortion and focal length. An adjustment really is inevitable to improve reconstruction quality, and some shots even won't be able to be solved at all without a proper lens. In our case, we don't have any information about the camera and lens used for filming this footage. The shot shows a certain amount of parallax, so it is possible to adjust the lens. Don't worry, we won't discuss this topic excessively. For a more detailed demonstration, please refer to tutorial Lens Distortion in section Tutorials at 3DEqualizer4.com. Okay, what do we need? At first, a tool to adjust the lens parameters. Select Config and Vertical Plane Parameter Adjustment window. Next, add some parameters. We will adjust focal length and distortion degree too. Finally, set all to adjustment method adaptive, then adjust. After a short while, we get new values for our parameters, improving reconstruction quality. Transfer parameters, and that's it. Let's calc the shot. Deviation is fantastic. It went down by 80%. The curve itself looks great as well, much more like a noisy flat line than previously. Deviation for box was improved as well, due to a simple lens adjustment. Have a look at the reconstructed scene in 3D space, so switch to 3D orientation controls. At first, since we'll concentrate more on box reconstruction, let's decrease the mesh's visibility a bit. Then zoom out. In addition to the already known scene of the first calculation, we see a second point cloud, the reconstructed blue box. Let's have a look at it by playing the sequence. The point group moves from left to right while rotating around the path. Pretty good reconstruction of the movements seen in footage. But something seems wrong when we look at both camera and box. The box seems huge compared to the wall mesh. It's nearly as big as the entire wall. What went wrong? Well, basically nothing. In a survey-free project, meaning we don't have any exactly measured 3D positions of points on the real-world set, it's impossible to determine the correct scaling. 3DE4 just sets a scaling depending on the amount and distance of track points. But basically, reconstruction quality does not depend on scaling. We can see this effect if the scene is scaled. In the Object Browser, select the C node. Then activate Manipulator Scale. The manipulator size can be modified with key minus for decreasing and plus for increasing its size. Okay, if we now scale the entire scene, everything in it is scaled accordingly. The distances between camera and 3D points and all 3D points themselves are changing relatively towards each other. Since everything is changing uniformly, and non-uniform scaling is obviously disabled, the solve stays correct independently from this scale. This behavior also applies on the object point group. It is calculated completely individually and therefore it's just impossible to calculate a scaling in relation to the camera. Here as well, if we scale the object point group, its relative distances stay correct at any size. By the way, unlike camera point groups, object point groups can be scaled individually from the rest of the scene. So, let's manually scale down the box until its size is approximately correct related to the size of the set. In Object Browser, select Point Group Box, adjust manipulator size, then scale it. Oh well, you didn't expect that, didn't you? A smaller size also reduces the distance towards the camera. It's a quite strange mathematical effect. For a better demonstration of this behavior, add Curve Editor to the main window. Then expand 3D Rod Path Curves and select Curve Path X. We quickly see the huge modifications of the box position curve. Every position and rotation curve is always modified in relation to the camera and highly dependent on it. One more thing, if the camera self is modified, for example by a new or changed tracking point, the object point group will be affected as well accordingly. Whereas such a modification of the object point group won't affect the camera motion at all. So we scaled the box pretty much. How does this affect the box reconstruction seen from the camera? Let's find out in Lineup Controls. But before, we should add CG content to the box for checking reconstruction quality, just like the wall mesh for camera point group. At first, add some geolines to the box. Select the points that should be connected by a line, then use shortcut Alt and L to create a line strip. Good. We have 3D tracking points on all sides, so add one line at each one. Then create a cube with 3D models, create cube. This cube should be placed on the upper side of the blue box. So select all points from this side. Then back in 3D orientation controls, add the cube to the selection. Then click 3D models, align model 2 points. At least 3 points are needed to get the orientation the cube should be aligned to. Great! Now let's scale the cube a bit to form some kind of a column. Good. Last, to differentiate the 3D models, change the color. Then switch to lineup. In addition to the wall mesh, we see 3D points and geolines on the box. Well, to see the lines better, let's decrease the size of the green crosses by selecting menu item, View, Show 3D points perspectively. As the name indicates it, with this option activated, 3D points closer to the camera are displayed bigger than those further away. Play the sequence. Yeah, looks really nice. The pink cube movements matches perfectly with the box. Okay, back to main topic of checking how scaling affects the reconstruction seen through the camera. To overlook all 3D objects of the project, open a second main window by selecting Windows, New 3DE4 window. And place it beside the existing one. Then switch to 3D orientation. Good. Again, make sure Pointgroup box is selected and activate button Scale. Then scale Pointgroup box. As we can see in lineup, the box points don't seem to be modified at all. As explained, 3D positions and box motion curve are relatively to the camera, so they are correct regardless of the scaling. But wait, there's one way to see the scaling here as well. If Pointgroup box is scaled so its position is behind the wall mesh, we see the pink cube is also behind it and just partially visible. Alright, we successfully reconstructed the box motion. But we still don't know about the correct scale and therefore the correct position in 3D space. This course demonstrates two different methods to determine the box position. The first one is an estimation with the help of nearby 3D points. When having a look at the footage, we see that the buttons of Trackboy's shirt seems to be roughly at the same depth to the camera. So let's track one of the buttons and use its 3D position to adjust the box position accordingly. Now, here comes a common mistake with multiple point groups. The point position we like to reconstruct will be part of the set, but at the moment, Pointgroup box is set to current. So creating a point will assign it to the box reconstruction, which won't help us at all. Always check which point group is set to current and which one fits for creating a point. Here, of course, set Studio to current. Then create a point on one of the buttons. Adjust tracking areas. And here comes another common mistake. This button clearly isn't a marker, but points type is set to it, as we defined in point defaults. Better change it to pattern. And if you like, for a better differentiation between both types, change its color. Finally, hit button Track. Okay, 2D tracking quality could be better, but it's sufficient. We can calc its position. But calculating the project with this roughly tracked point might reduce the overall reconstruction quality. We just need its position in 3D space, so maybe there's a way to do that. Of course there is. Since we already have a solved shot, we can just triangulate its 3D position without influencing the solve. With the point selected, go to Attribute Editor and set parameter calculation to passive triangulate position only. The status is also displayed in Point Browser. Then calc all again. Nothing's changed. At least nothing we can see here. Back to 3D orientation controls. And choose the top view for a good overview of all positions from camera to the wall. And there it is. The yellow point is our selected and triangulated point. So now we have a clue where the box should be positioned. Now simply scale Pointgroup box until the point cloud is beside the yellow point. Great, that's it. This is not the most precise way, but a common technique for estimating a 3D position, and after all, still way more precise than just guessing. The second method is more precise, but requires measurements from set. More precisely, measurements from the set and the box. So if you're lucky enough to have measured distances of features or markers, here's the way to use them. At first, we need to bring Pointgroup Studio to real-world scale. Therefore, we select points 1 and 2 above the box. Then enter the distance that was measured on set. Back in 3D orientation, open, constraints, create distance constraint. The value in the text field displays the current distance of both points, but we need the real one, so enter 90.1 centimeters. Great! Our reconstructed set is now scaled correctly. By the way, a specific label for distance value is located between the 3D points used for this constraint. We set an exact distance value for our 2 points, defining the exact scaling of the set, so it cannot be manually scaled any longer. However, it is still possible to scale Pointgroup box, so of course, we need a distance constraint here as well. Set Pointgroup box to current point group. Then select the middle and upper left point. Next, open again, constraints, create distance constraint. Then enter a distance of 16.8 centimeters. Click button OK. Both point groups are now scaled precisely. We see the point group's position again is approximately beside the button point, proving the previous estimation was already quite precise. We also noticed that Pointgroup box cannot be scaled anymore. The scale of these objects is now defined by their constraints. Great! We successfully solved the shot. Both camera and box could be reconstructed and scaled precisely. Let's have a look at the final result in Overview Controls. And for an impressive overview, hide all panes with Shortcut tab. Nice, all 3D objects are displayed, so let's play back the sequence. Please note, the first playback might be a bit slower since 3DE4 caches all images for the possibility to render and save them to a hard disk. Everything looks perfect. Good job. This tutorial demonstrated 3DE4's concept of multiple point groups to reconstruct the camera and individually moving objects at the same time. We learned how to create camera and object point groups and how to organize 2D tracking points in the correct ones. Further, we scaled them properly by estimating the object point group's position with the help of a triangulated point and defining their scale precisely with distance constraints. That's it. Thank you very much for watching. I hope you enjoyed this tutorial.